Good morning, everyone. Thank you again for attending this morning's science sharing webinar. This morning, we're focusing on the HREF Ensemble visualization page, insights and operational applications. This morning, we are fortunate enough to have Dr. Jacob Radford with us. He is a data visualization researcher working with the Cooperative Institute for Research in the Atmosphere, or CIRA, and NOAA GSL. He received his bachelor's in atmospheric sciences from UNC Asheville and his master's and PhD from North Carolina State under the advisement of Dr. Gary Lackman. His work is interdisciplinary, incorporating elements of meteorology, computer science, and science communication. And his primary interests are focused on operational implementation of data visualization techniques. So with that, Jacob, thank you so much for being with us this morning, and the floor is yours. Thank you again.
Awesome. Thanks for that introduction. Let me see if I can share the right window here. All right, so yeah, I'm excited to be here today to share some of my PhD work. I completed that in August. There were a few different components to my dissertation, some using machine learning to improve forecasts of mesoscale snowbands and heavy snowfall. But what I'm going to focus on today is the portion of my PhD where I developed some novel ensemble visualization tools for the HREF specifically, but also hopefully some of these can be adopted for other ensemble systems. So this project all began at the 2017 Weather Prediction Center's annual winter weather experiment. So my advisor and I attended, and we drove back together to Raleigh, and we were discussing that there's a real need for development of better ensemble visualization tools, and somebody really needs to take steps to address it. And as far as we knew, nobody was currently taking steps to address ensemble visualization in a really robust way, and especially for winter weather. Neither of us were really experts in the area, but we thought with our skill set, we were well suited to try to tackle this problem. So we put together an interdisciplinary team. It was Dr. Gary Lackman, who is an expert in meteorology, Dr. Jean Goodwin, who is a science communications expert and also a social science expert, Dr. Christopher Healy, who is an expert in computer science, as well as data visualization, and me, who had no real expertise, but had a lot of enthusiasm and optimism. So together we wrote a C-STAR grant, and ultimately we're lucky enough to get funding to do this work for my dissertation. So this is some less anecdotal background for this visualization page. Improved probabilistic products and improved IDSS tools are critical goals for the AMS and the National Weather Service. A lot more work is focused on severe weather in this area. So there's the annual spring forecasting experiment where there's a lot of effort devoted into evaluating new guidance products. There have been several other studies on ensemble visualization techniques for severe weather, coming up with things like paintball plots and neighborhood probability plots. Relatively little has been done for winter weather, in my opinion. There have been some good work coming out from Novak et al. In 2014 and Demuth et al. In 2020. But I think compared to severe weather, there's a real lack in winter weather. And at the outset, we envisioned developing something like the SPC's HREF Viewer, which I suspect most or all of you are familiar with. This is a fantastic tool that's developed and maintained by Dr. Brett Roberts at the SPC. And it's really a one-stop shop for HREF visualizations. So all of the basic things you want, looking at the mean or the median or max values of different fields are available here. And we wanted to develop something that was kind of like this, just with more creative and innovative visualization techniques, and not just looking at those statistical summaries like the min, the mean, and the max. We wanted to have a winter weather emphasis as well as an IDSS emphasis, given National Weather Service's goals there. And we wanted to have a more modernized platform rather than just producing static imagery like this page has. So our strategy for this was we started with a question, which is how do we make valuable products that forecasters will actually use, not just products that look nice, that can fill out a dissertation and then ultimately sit on the shelf. And the best way to do that, social science literature has found, is co-development with forecasters, which is where you're in constant contact with forecasters, bouncing ideas off one another. So that's the ideal scenario, but that can be pretty costly in terms of time commitment. A more feasible approach was just to use iteration. So we had an initial focus group with winter weather forecasters at the annual winter weather experiment. Then after that, we did prototype development based on the feedback we got. We presented our prototypes to a follow-up feedback group, which was the winter facets team. We did some more minor product refinement. And then ultimately, we did a series of evaluation experiments with national weather forecasters to get to ultimately assess the utility of the new graphics that we developed. This is more details of what that procedure looked like. So in March of 2020, we did our preliminary focus group. This had components. The key components here were evaluating the current state of Ensemble visualization, gathering input on needs for new products, and really just beginning a dialogue with the operational community. Then we designed our products based on that feedback and developed a system for pseudo-operational implementation, which is the page that I'm going to be sharing. In September of 2021, we had our follow-up feedback group with the facets team, where we determined the products with the greatest potential and ideas for further refinement. And then we had 3 evaluation groups, which were in December, January, and February of the 2021-2022 winter. These were 3 groups organized by the Weather Prediction Center with a total of 53 forecasters. And what we did was we split the groups into control and experimental groups. And the control groups had access to the SPC's HREF Viewer page. The experimental groups had access to the HREF Viewer page as well as the experimental graphics. And then we asked them to perform just a simple exercise on winter weather timing. So we asked them to forecast things like the onset time of different snowfall rates for a few different locations and the duration of snowfall rates at a few different locations. To get forecasters to interact with these tools primarily, but also as a measurement of how accurate the 2 groups were in this forecasting exercise. Then we asked the experimental group for Likert scale feedback. This is when you take a survey and it asks you, do you strongly disagree or strongly agree with this statement? So we asked them about 4 things: whether the graphics helped reduce their task workload, whether the graphics improved their uncertainty comprehension, whether they had utility in operations, and whether they would communicate the information in the graphics to their core partners. And then finally, we had follow-up discussion where we just had more qualitative feedback from the group. So these are the takeaways from our preliminary group. So again, we asked about the capabilities of current visualization platforms such as AWIPS, their forecast procedures, particularly for mesoscale snowbands, because at this point in the process, we really thought that's what we were going to focus our efforts. That's what I had previously been researching. But after that, we kind of opened it up to heavy snowfall in general. And then also what Ensemble products they commonly utilize in their forecast process. And the takeaways here were that there were limited probabilistic AWIPS tools, and cloud tools are really prevalent. Forecasters are really good at finding these tools, whether it be on Pivotal Weather, Tropical Tidbits, the SPC's HREF Viewer. It doesn't need to be in AWIPS for them to find it. They wanted both diagnostic probabilistic information on things like frontogenesis and stability, as well as IDSS probabilistic tools. The most important thing that came out of this was forecasters really wanted products that addressed the temporal aspects of events. So when an event is going to start, how long it's going to last, how impactful it will be. Forecasters also wanted interactivity in the graphics. So some degree of being able to look into the data and find out what the sources of what is contributing to the uncertainty in our visualizations is. And more generally, there was an acknowledgement of visualization needs. But there wasn't a clear concept of what the new visualizations could look like, because ensemble visualization is a difficult problem with really high dimensionality data sets. It's hard to conceptualize what this would look like in digestible format. So the first thing we did in our development was decide on our visualization platform. And we decided this should be web-based leaflet maps for a few reasons. So of course, it's cloud-based, so this increases accessibility. Anybody that has the URL can access it. Leaflet maps have zooming and panning capabilities, so they're kind of scale independent. You can focus on areas you're interested in. Relatively simple toggles and temporal controls are available, as well as toggleable overlays, so whether you want to overlay topography or things like that. And then it also offers capabilities for hover readouts or sampling. So you hover your mouse over and return the data value from the image. And then we wanted to have a real-time application to HREF to show that this could really be done in a timely manner, that it was really a feasible idea for operations. So currently the website works on a 3-hour latency. So images are produced within 3 hours of the HREF data becoming available. And I'll just add the caveat here that it's experimental, so it may experience downtime. I'm absolutely not a web developer, but I'm maintaining it as best as I'm capable of. So now we get into some of the specific visualization tools that we worked on. There are, we grouped them roughly into 3 categories based on their purpose. So the first category is event magnitude and general uncertainty. So this is more along the lines of things you'd see in the SPC HREF Viewer, so statistical summaries like the mean, median, standard deviation, different percentile levels, exceedance probabilities, so the probability of exceeding some chosen threshold, as well as paintball plots. In general, these products aren't new, but we thought they might be more useful when coupled with the new, more interactive platform. The next category is products that deal with the characteristics of an event, such as precipitation type probabilities, probabilities of a mesoscale snowband developing within the event, and postage stamps, because you can look through each individual member solution and see what the precipitation structure looks like. And then the last category are products that deal with event timing. So things like the onset time of different snowfall rates or the duration of different snowfall rates, as well as the potential for occurrence of heavy snowfall during high impact time periods like rush hour. So soon I'm going to jump over to demonstrate the website, but first I wanted to explain some of the less intuitive products that we have on there. So first is a product that we refer to as attribute blocks. So here, each pixel color in an n by n block of pixels, so for example, a 3 by 3 block of pixels here, within the grid is controlled by one ensemble member. So if all ensemble members were the same, this would result in a really smooth image that was identical to each individual member. But with greater uncertainty, diverging adjacent colors like the yellow here and the white here and the green here, so this region, it gives a more mottled appearance. So this is an example of this applied to radar reflectivity. So you can see where there's relatively low variance, where all of the members have this deep green value. Whereas offshore here, you get some members predicting more like 40 dBz or 50 dBz, and some producing almost no reflectivity. So there's relatively high variance here. So this product represents some level of both kind of the average magnitude of the event as well as the uncertainty of the event. And we can, a benefit of this attribute block technique is we can apply it to other visualizations. So we can apply it to the paintball plot, for example. The paintball plot is common for identifying where individual HREF members or any ensemble member will exceed a given threshold. But a problem with that is that it depends on the order that you draw these members. So the last member that you draw is going to include the members underneath it. Whereas if you use these attribute blocks, it sort of interlaces the individual members rather than including them. So you can see where there's overlap between the members and where some members are just out here on their own, like this orange member over here. Next, we have the precipitation type probability plot, or a ternary plot. So we generally think of precipitation type in terms of the four main categories: rain, snow, ice pellets, and freezing rain. If we make a big sacrifice and combine ice pellets and freezing rain into one ice category, then we can represent the probabilities of each category with a color channel like red, green, or blue. So blue in this image represents 100% probability of snow. Green represents 100% probability of rain, and red represents 100% probability of ice. But then we can also see where there's uncertainty in this image by the different mixtures of colors. So where you have kind of a purplish color, meaning there's like 50% component coming from the blue and 50% from the red, that would be 50% probability of snow and a 50% probability of ice. You can do that for every combination. So 50% probability of ice and rain would be this kind of brownish color representing red and green mixture. And then teal would be a 50% probability of snow and 50% probability of rain. And then if you have even probabilities of all three categories, you get kind of this gray color in the middle. Next is Snowband probability heat maps. And this is something that extends from my master's work, so we just wanted to include it. So this uses the simulated reflectivity of each individual HREF member to extract the mesoscale snowbands within the region. And then it overlays the extracted mesoscale snowbands to produce a probabilistic heat map. So applied to these 9 members, this is where there's roughly a 50% probability of a snowband, for example. Next is a graphical rather than a contoured product. So our goal here is to draw attention to high impact periods. In order to do this, we want the high impact period to have the largest area to draw the viewer's eye. So the bar height in this case represents the probability of precipitation. The bar width represents the average precipitation rate. So the highest confidence high rate times will have the largest area and draw your eye, and those are presumably the times when there will be the largest impact. In addition, we've encoded additional information in the colors of the bars. So the conditional probabilities of rain, snow, sleet, and freezing rain are represented by the colors. And on the website, these are interactive. So hovering over a bar shows the exact probabilities of each category, as well as the average rate. Now, the last 3 products I'm going to show here are the 3 timing products. These are adapted from Demuth et al. 2020. So the first one shows the snowfall rate onset. So this answers the question, what time will 0.1 inch per hour snowfall rates begin at a particular location? Where this differs from Demuth's work, other than adding the kind of interactive component, is this slider up here allows you to control whether you're looking at the median onset time or you're looking at the 10th percentile, which would be near the earliest onset time from the HREF output, or the 90th percentile, which would be near the latest onset time. The snowfall rate duration product is very similar to the onset time product. So how long will 0.1 inch per hour snowfall rates last at a particular location? Again, this is adapted from Demuth et al. 2020. Where this differs is you can also look at the shortest potential onset time using the 10th percentile and the longest potential onset time using the 90th percentile. And then finally, our last timing product calculates the probability that snowfall rates will exceed the chosen threshold between the hours of 7 a.m. and 9 a.m. or 4 p.m. and 6 p.m. local time. So this answers the question, will it be snowing harder than whatever rate you choose during rush hour? And you can toggle the rate that you're looking at, whether it be 1 inch per hour or 0.5 inches per hour, up to 2 inches per hour. So now I'm going to stop sharing my screen and share the website itself. So this is what the Ensemble visualizations page looks like. The current URL that I'm using is visweather.com, just to clarify. You might have seen previous versions called ensembleviz.com or wxnviz.com. They all go to the same place now. So no matter which one you have, it should go here. But just to orient you, we are currently looking at the HREF initialization from this morning at 0 UTC. This is the leaflet map zooming and panning capabilities. So I'm primarily going to focus on the hourly snowfall field here, just to give you guys examples of the products that we've developed. But you can also look at 1,000 meter reflectivity, composite reflectivity, QPF fields, and snowfall. So of course we have the basic statistics like the mean and the median. Up in the upper right of the map, we have the slider control, which controls the forecast time. You can also use the arrow keys to control that. In the very upper right corner, we have a question mark you can hover over, and it gives you information about how the products were developed. Like I mentioned, you can have zoom capabilities using the upper left controls. And then we have hover controls. So when you hover over a particular location, it gives you a readout of what the actual value is at that location. So I'm hovering over a 0.7 inch per hour snowfall rate right now. Of course, we have the median as well. Next is the percentile plots. So you can control the actual percentile threshold that you're looking at for the hourly snowfall from the 10th percentile up to the 90th percentile at 20% intervals. Postage stamps are pretty self-explanatory. So each of these maps is controlled by a different HREF member. What I think is cool about our implementation is that when you use the first map to control the postage stamp, it controls all of the maps at the same time. So you can really see how the different ensemble members differ at varying scales. Exceedance probabilities are showing the probability of exceeding whatever snowfall threshold you're looking at. So I'm looking at probability of exceeding 1 inch per hour snowfall rates right now. You can toggle that looking at 1/2 inch per hour snowfall rates up to 2 inch per hour snowfall rates. Next is that attribute block plot that I showed in my slides. So this is representing all of the different member solutions in 3x3 blocks of pixels. So for example, if you carve out a 3x3 block of pixels, each one of those pixels is represented by one ensemble member. So this gives you kind of a sense of the uncertainties. For example, there's more uncertainty down here where it looks like 1 or 2 members are forecasting very high snowfall rates, and the rest are forecasting relatively low snowfall rates. So now we're getting into the temporal products again. So this is the onset time product. This is showing the most likely onset time or the median onset time of 1 inch per hour snowfall rates. You can control whether you're looking at the median onset time or the earliest potential onset time or latest potential onset time, as well as controlling the rate that you're looking at. So whether you're looking at the onset time of 1 inch per hour or 1/2 inch per hour up to 2 inches per hour. This is the same thing just for the duration of snowfall, how long the snowfall is going to last. And then the last temporal product is the rush hour probability product. So the probability of exceeding 1 inch per hour snowfall rates during the rush hour period, 7 a.m. to 9 a.m. or 4 p.m. to 6 p.m. Then our Snowband products are in a separate tab over here. So this is the HREF probability of experiencing a snowband. Relatively low probabilities right now. The precipitation type product, so that ternary product is shown here under the precipitation type tab. And then lastly, the precipitation type mediagram, that more graphical product we produce at 1/4 degree by 1/4 degree intervals. So you just click on a location on the leaflet map and it generates the mediagram for you. Hovering over the bars shows you the precipitation type probabilities as well as the average rate. So now I'm going to stop sharing again and share my slides again, if I can make it back there. Okay. So we presented all of these products to the Winter Facets team. We presented the platform and the prototypes, and we really needed to narrow our focus in these visualizations because we couldn't evaluate all of them. So we really had to pick the ones that had the greatest potential utility. And the takeaways from this feedback group, which was relatively informal, were that the web-based leaflet platform was the way to go. It was very helpful in looking at different scales and different locations. Temporal products were the most valuable, especially in the context of IDSS. And furthermore, visualizations should focus on snowfall rates rather than total accumulations or looking at simulated reflectivity, for example. So ultimately, we chose those temporal products, so the onset time plot, the duration plot, the rush hour plot, to present to forecasters for evaluation. And I will note that we also included the Snowband probability plot just because when we started, we thought that would be a really interesting product. And it was based on my master's work. So there were a few reasons we wanted to include that as well, but it didn't strictly align with what forecasters said they wanted in the initial group or in the feedback group. So again, this is how we did the evaluation. First, we wanted to know if products influence forecast accuracy compared to existing tools. So we had forecasters do a simple forecasting exercise, just answering questions like when will snow begin at a given location? How long will the snow last at a given location? The control group used the SPC's HREF Viewer, and the experimental group used the SPC's HREF Viewer as well as our experimental products, so they had access to both. And then we asked them the Likert scale evaluation, answering these 4 questions. Would forecasters use these products in operations? Would they communicate the information to core partners? Do the products reduce time spent on forecasting, specific forecasting activities related to event timing? And do the products help forecasters to interpret HREF uncertainty? So first, the forecast accuracy test results. There was little to no difference in terms of forecasts of snowfall onset time. And there was also little to no difference in forecast ranges of outcomes. So we asked forecasters to forecast the most likely onset time as well as the latest potential onset time to kind of see how they were interpreting the HREF uncertainty. But there was little to no difference, it seems, in how they were interpreting the uncertainty. The experimental group showed lower mean absolute errors for snowfall durations, but those differences weren't robust given that we had relatively small sample sizes. So the lack of difference in accuracy was pretty much an expected result. So the underlying HREF data that both groups were looking at was the same. It was just how they were being exposed to the data that was different. And this was also the first time that forecasters had been exposed to these experimental products. So there was probably some spin up and learning curve time. But what we really wanted to know was we wanted to ensure that there were no negative consequences associated with the new products. So the new products aren't confusing forecasters. We aren't encoding information inaccurately. And the fact that there was almost no difference in terms of forecast accuracy kind of shows that that was the case. So now we'll look at how the forecasters responded to the utility of each product for various purposes, starting with the snowfall rate onset time product. So to orient you on this diagram, the red colors are indicating disagreement with the statement. Darker red would be strong disagreement. Gray is neutral to the statement. Light blue would be agreement, and dark blue would be strong agreement. So the first question was, would you use it in operations? And there was pretty strong agreement across the board that they would use it in operations. And they would also communicate the information in the products to their core partners. In general, forecasters felt that the onset time product improved their comprehension of the HREF uncertainty in terms of event timing. And they also agreed that it reduced the task time, but there was less agreement here. And the main reason we think this is we had a relatively poor color mapping. So it was relatively difficult for forecasters to translate the information from the contoured map to the legend, because what we did was we had the legend in terms of forecast hour rather than valid time. So forecasters had to do an additional mental calculation where they had to add the forecast hour to the initialization to get the actual valid time. So next is the evaluation of the duration product. In general, it closely resembles the onset time product. So forecasters felt they would use it in operations and communicate it to core partners. It improved their uncertainty comprehension. But here, there's a lot more agreement that the product reduced task time. This is probably for a couple of reasons. First of all, we used a better color mapping. There were no additional mental calculations that forecasters had to do to calculate, like a valid hour. It was just the raw number of hours of exceeding the snowfall rate threshold. And it also helps reduce task time because previously, if you're using just the SPC's HREF Viewer, for example, you have to look at every individual time step and add up how many hours you're exceeding the snowfall rate threshold, whereas our product just gives it to you in one image. The rush hour probability product probably had the greatest overall agreement, with a greater proportion of forecasters strongly agreeing that they would use and communicate the product, and that the product reduced task time and improved their uncertainty comprehension. So this was forecasters really responded strongly to this product in a positive way, but they also had a lot of comments and a lot of ideas for improvement, which I'll get into in a second. And then lastly, I mentioned that we also included the Snowband probability product that didn't strictly align with what forecasters said they wanted. And you can really see that reflected in the responses to this product. There's a lot more disagreement here that forecasters, they were a lot more skeptical to use it in operations, and especially to communicate the information to core partners, because they didn't have enough context. They didn't know how, the details of how this product was developed. And furthermore, a lot of forecasters didn't necessarily care whether there was a snowband so much as what the actual snowfall rates were, whether it was heavy snowfall or not. And certainly their core partners don't care whether there's a snowband or not. It's more of a meteorological interest. So more qualitative feedback was extremely positive overall. One forecaster said these products are right on the money. Another said they would be a huge asset in operations and in IDSS. Those are just a couple cherry-picked comments. Of course, we had criticisms and suggestions for improvement. Forecasters wanted better color maps and color bars, which we've since implemented. They wanted greater granularity in the color bars. So everything was previously in 3 hourly bins, but because we're looking at high resolution data, they wanted 1 hourly bins. We've since added the hover readout feature that I showed off before. And then forecasters wanted rush hour customizability. So back to that probability of snowfall during rush hour product. Forecasters in all three of our groups said that they wanted the ability to choose and define when rush hour is for their specific purposes, because rush hour is not the same for every city. So in just a second, I'll show how we address that. And then the last thing forecasters said they wanted frequently was different snow to liquid ratio treatments. So on our website, everything is either in liquid equivalent or it just uses a 10-to-1 ratio. So forecasters wanted the ability to choose to toggle different snow to SLR ratios. So getting at that kind of customizable rush hour product, we developed two final products that weren't evaluated, but were developed based on the final feedback we received. I refer to these as the interval products. So the interval exceedance probability between any two user-defined hours, what is the probability of exceeding the chosen snowfall rate? And the interval durations product, which is answers the question between any two user-defined hours, what is the mean proportion of time that the chosen snowfall rate will be exceeded? So now I'll jump back to the website one more time. So looking at hourly snowfall again, here we have the, let me refresh the page, the interval probabilities. So the probability of exceeding whatever snowfall threshold we're looking at, in this case, 1 inch per hour snowfall rates between the user-defined start time and the user-defined end time. So between 10 UTC and 16 UTC of today, at this location right here, there's roughly 50 or 60% chance of exceeding that probability that 1 inch per hour snowfall rate threshold. And then the interval duration product. So again, choose a start time and an end time. And then this shows you the proportion of time between those hours that you would be experiencing 1 inch per hour snowfall rates. So down here, there's a 90% probability of exceeding, it would be snowing at 1 inch per hour at a 1 inch per hour rate for 90% of the time between this period, 9 UTC to 14 UTC period. Okay. So our conclusions are that the iterative process that we used helped produce products that met a critical forecasting need. Forecasts made with the new products that we developed were at least as accurate as those made without new products, and may have reduced errors in duration forecasts. Forecasters agreed that the products reduced their task workload, improved their comprehension of HREF uncertainty, and that they would use the product in operations and communicate the products to core partners. And ultimately, this project led to the development of a pseudo-operational product that I'm still maintaining, which is this website that I'm demonstrating that shows off the feasibility of visualization tools like this and the efficacy of tools like this. Moving forward, I'm going to keep maintaining the real-time capabilities of the website indefinitely. Right now, I have a relatively long archive of data. I'm going to change that to just having a rolling 1-week archive of HREF initializations you can look at just to save storage space and computational power. Going to keep implementing bug fixes. There are a lot of bugs, and if you find any, feel free to email me with those. Now that I'm working with NOAA GSL, I've been exposed to some other products that have used WebGL in a really cool way. So I'm thinking about trying to incorporate that into the website. And then there's also some consideration of transitioning some of the Temporal products over to WPC just to have an additional outlet with a more capable web development team than me to maintain those products. These are the references I used, but I'm happy to answer any questions anybody has at this point.
Jacob, first I'll start off by saying thank you again for presenting all this regionally and nationally. People across been beyond Eastern Region on this call. Really appreciate all the great information on this site and everything that went into the development of all the different products. As a reminder to everyone online, this Look For Us again was being recorded. So we will have this uploaded to our Eastern Region Science Sharing page shortly after the conclusion of this webinar. But as far as questions, I'll start off with one myself. So the Snowfall onset time and duration product that you spoke about, you said it had a 0.1 inch per hour threshold. Now, I know you mentioned with the interval duration, the interval products, you can specify the time and the threshold. Is that locked in, though, for the onset time and the duration products as far as the 0.1 inch threshold goes, or is that also adjustable? You may mention it quickly. So.
Yeah, so you can also control that. I'm not sharing my screen anymore, but you can toggle that between 0.5 inch per hour snowfall rates up to 2 inch per hour snowfall rates. Which of course would be, 0.05 to 0.2-ish liquid equivalent if you're using just a 10-to-1 ratio. So yeah, there are 4 different thresholds that you can choose from for both the onset time and the duration products.
Great, thank you for that. I appreciate it. I see you're getting some kudos as well in the chat. Are there any other questions from folks in the field? Dave, go ahead.
Yes, Jacob, can you hear me? Because I'm on a different computer than I'm used to.
Yes, I can hear you.
Great. So I see a lot of, first of all, this is great. We were able to use this at least in partial real time for a January 17th event back in 2022. So it was kind of neat to see it in action. Side note, we'd love to have a archive of that event. We have screenshots, but we don't. Love to look at it again.
Yeah, if you send me, the initializations, the HREF, specific HREF initializations you're interested in, I can produce that.
Okay,
image.
I'll email you separately on that.
Okay.
Since you're at GSL, I know there's you might be familiar with this thing called DESI that a number of offices have been playing around with.
Mm-hmm.
I'm not sure where things are going, but obviously there's a parallel track here. I'd love to see some of that stuff either incorporated into your thing or in your stuff incorporated into that, because I think it would be fantastic.
Yeah, DESI is actually something I was recently exposed to, and have been talking to Travis Wilson, I think is his name, some. Yeah, that's a really powerful tool. That's why I said in my kind of future work slide, I'm going to be investigating some WebGL, which is what he bases his website on. But yeah, you're absolutely right. There's kind of a parallel track between, what we've been developing, and but we're communicating now about how, we can kind of incorporate different aspects of our two different projects together.
All right. Thank you for that question, Dave. Absolutely, there is some legitimate overlap between the two viewers, so it'll be interesting to see where that can go as well moving forward in time. I see also a question from Pete. Did you want to elaborate upon that question, Pete?
Yeah, I was just looking through the some of the tools you've got on the website there, Jacob. Great job, by the way, with the presentation. I didn't see a cessation time. You've got the onset time for the different precip rates. It's good to know the ending time as well. I don't know if that's something that your team had considered.
Yeah, the cessation time is something that we can add relatively easily. It kind of, if you use the the duration and the onset time, you can kind of get at that. But yeah, the actual, we can add the actual cessation for sure. We weren't sure if that would be as interesting to forecasters as the onset time and the duration.
Yeah, we get requests from our partners sometimes for when the heavy snow is going to end, for example. So
okay, yeah, that's
probably be useful. So
yeah, that's good to know.
Appreciate it.
Okay, thank you for that. I don't see any, unless I'm missing something. I don't think there's any more questions I've missed. I'll give another moment. Frank, go ahead.
Yeah, we're just a comment. I haven't seen this before, and I love this. I think we talk a lot in our agency about improving our modeling, and I don't think we spend enough time talking about improving our post-processing and being able to see effectively the data that we actually already have. So efforts like this, I think, are terrific, and I thank you and your team for your efforts.
Yeah, that was a kind of a key consideration for my PhD, was we have a lot of data that's just underutilized, and how can we better utilize that data by applying different techniques. So applying machine learning to the data that we have, applying different visualization tools to the data that we have. So rather than creating new data, just using the data we have in different ways.
Okay, I'm seeing a comment in chat from Steve Zubrick. Yeah, no, it's an interesting point to consider moving forward. As we transition to different precipitation product generation approaches moving forward. Was there a question there, or just a comment?
No, it's just more of a comment.
Okay.
Just for IDSS, it would just seem like it'd be nice if we were all on the same page. But and I would just say from the get-go, creating a winter precip onset graphic, there's so many ways that you can do it, and there's advantages and disadvantages to those ways too. But the sense that we get down here is that our users prefer for semi-organized events, for headline-worthy events, certainly something that's fairly uncomplicated and kind of smooths out some of the details. I'm not saying that that's perfect for everyone, especially for those in, maybe in lake effect and or mountainous terrain, but that's kind of what we find here.
Yeah, that's producing the onset time product. It can be messy at times, especially if especially if there are multiple systems, and if you're it's one thing if you're hand drawing the onset time, for example, but if you're using if you just have a program computing the onset time and they're kind of intersecting different systems, it can get really messy, and how you smooth that out can be tough. So it depending on the context, it can be very complicated. I think that's less the case for winter weather than if you're looking at severe weather. The initial prototype for the onset time product that Julie Demuth developed was applied to severe weather, and it was just very messy because there's so much going on and things are moving very quickly. For winter weather, it's a little bit easier.
I mean, your methodology would certainly help us get the grid created, and then going from there, we have to take something from our grids to actually create the onset grid. Right now we're evaluating Evan Bookbinder's software to do the Precip onset that uses some basic parameters from NDFD to do that. Yeah. And there's some smoothing factors that you can put in there. So it's the partners, for an organized event or a widespread event, headline worthy, let's say, they need kind of a ballpark number. Yeah. They're not looking at down to the minute. Certainly airport users are a different beast, and they want to know when the Snowband ends so that they can get out and clear the runways, for example, and get the airport back open as soon as possible. So there's different groups of users.
A great point, and it sounds like it's an ongoing question to ponder and consider is how we best develop these products moving forward, in concert with also products like Prop Snow and other things of that nature. Okay, looks like Dave's have sent the case they were interested in as well, in getting the access to that data. So in chat. Okay. Are there any other additional questions or thoughts? Okay. If not, again, thank you, Jacob, to you for being willing to present all this great information to us in the field. Really appreciate all the insights and great information on how to best leverage this data moving forward for operational purposes. And of course, as I mentioned before, this is all being recorded, so this will be uploaded to the Eastern Region Science Sharing page after this webinar. So thank you again to everyone, and Jacob, thank you so much.
All right, thanks everyone.